All right, here we are continuing on with the practice final solutions. We have number 11, f of x equals 2x plus 2, and g of x is x squared minus 2x, and we are asked to find f of g of x. So what I'm hoping you all notice about this problem is that we have the f, these parentheses, and then the g of x is inside of the f parentheses. The g is inside of the f. So what we do is we look up here at the g equation. We take what the g equation is equal to and plug it into any x that's in the f of x equation. Okay, so in other words, what that should look like is the 2 and the plus 2 stay exactly the same. All we do is replace the x with x squared minus 2x. Okay, so I hope we all see that that looks exactly the same with the exception of this x has been replaced with x squared minus 2x. And then we are distributing what is outside of the parentheses, so we get 2x squared minus 4x plus 2. That is f of g of x. That is the end of that problem. So you guys can see that some of these problems take literally like a matter of seconds, and others take a little longer. That one should not take too long if you know what you're doing. All right, let's keep going. All right, so I have my practice final here, so let's see. The next one is 3 over 2n plus 3 minus 3n over 3n squared plus 3n. Let's move this over here so you can see it a little better. All right. So here's what we're doing in this problem. I hope we all noticed that we have a couple of fractions that are being added together. And the rule with fractions, again, is that you have to have the same denominator to be able to add or subtract. So the first thing that I notice is that this second denominator has, they both have something in common. And that something would be a 3n. So we can factor it out, and you don't have to do this in the beginning, but it makes your life a little bit easier overall in the end. So if we factor out the 3n, we're left with n plus 1, and then I notice that we have a 3n and a 3n here. Well, anything divided by itself is 1, so we're going to do that so that we're reduced. So we are left with, let's move this up, make sure you guys can see. So we're left with 3 over 2n plus 3 minus 1 over n plus 1. So again, like we just talked about, the rule with fractions is that you have to have the same denominator to be able to add or subtract. So now we want to go through and get these to have the same denominator. So this one has a denominator of 2n plus 3. This one is missing 2n plus 3. So we're going to multiply both the numerator and denominator by 2n plus 3. And the reason we have to do both the numerator and denominator is that if you divide something by itself, you are essentially, you end up with the same number, or number 1. Okay, so in other words, 2n plus 3 divided by 2n plus 3 is 1. So multiply that by that side. So we're not changing that fraction, we're just proportionally increasing it by 2n plus 3. All right, we're going to do the same thing over here. So this one has a 2n plus 3, but it's missing an n plus 1. So we multiply n plus 1, and then we distribute. Distribute, sort of backwards distribution on this one. So we end up with 3n plus 3 over n plus 1 times 2n plus 3 minus 2n plus 3 over n plus 1 times 2n plus 3. And last thing we're going to do is distribute this minus to both of these and combine like terms. So we get 3n minus 2n is n. Again, make sure you guys can see, you can, okay? And 3 minus 3 is nothing. So you get n over n plus 1 times 2n plus 3. And that is the end of that problem. All right, next, moving right along, number 13. Number 13, we've got 3x squared minus 6x plus 3 divided by 2x squared minus 2. Okay, good, you guys can still see that. All right, so again, always looking for greatest common factor first. So our question asked which quotient is equivalent to this one. So on the top, I can factor out a 3, and I'm left with x squared minus 2x plus 1. And on the bottom, I can factor out a 2, and I'm left with x squared minus 1. From here, what we end up with is on the top a perfect square trinomial. And a perfect square trinomial factors to x minus 1, so in this case, x minus 1 squared. The bottom one, we have 2, and then a difference of 2 squares, which factors to x plus 1 and x minus 1. All right, so now we're looking for anything that we can reduce from here. So we have 2x minus 1s on the top and 1x minus 1 on the bottom, which means one of them gets canceled out on the top with 1 on the bottom, and that looks like it for this problem. So we're left with 3 times x minus 1 over 2 times x plus 1. Okay, let's see. Let me look at number 14 and see. We're going to switch over to another video to do number 14.